everyone, and welcome to our webinar on the science of cloud access, Demystifying IAM for beginners. I am Nandini Bharadwaj, the operating officer at CyberWarFare Labs, and I'm excited to have you all here with us today. So let's get started. So before we start, let me tell you a bit about us. CWL is a leading cybersecurity infosec company offering comprehensive solution to help individuals and organizations to develop essential cybersecurity skills. Our offering includes learning management system platform. So this platform provides enroll user with course study materials, which includes HD videos and PDFs for a wide range of cybersecurity courses. The second one is CWL Cybersecurity Playground, that is CCSP Playground. So this platform offers theme-based labs designed to simulate real-world scenarios. User can start the labs at their own convenience, providing flexible hands-on practice. And the third one is Infinity Learning Platform. It's a plug-and-play platform offering immersive learning experience with challenges across red, blue, and cloud security domain. It's currently free, so if you want to enroll in this platform, you can enroll now. I'll share the link in the text box. So, and also CWL supports customized on-site training requests and accept bulk orders for corporate training needs. For more information or to place an inquiry, contact us on support@cyberwarfare.live. So let's move on. Okay, so let me introduce to our speaker of today's webinar. So our today's speaker is Abhijit Kumar. Abhijit is a security researcher with an expertise in red team operations, network security, cloud infrastructure, and Linux systems. He is also passionate about researching adversarial tactics, techniques, and procedure, and frequently experiments in his home lab. So we are excited to hear his insights today. So that's all about the speaker. And dear participants, as promised, we are excited to share that you will receive your attendance certificate along with the video recording of the webinar within next 48 hours. So thank you for being part of this webinar and we'll look forward for your continuous participation. So here, without further ado, I would like Abhijit to take over and let's get.
Yeah, hi. Am I audible?
Yes, Abhijit, you are audible. You can start the webinar. Over to you.
Okay, I'm gonna share this screen in a moment. Please let me know if the screen is shared. Can anyone confirm if the screen is visible?
Yes, the screen is visible, Abhijit. You can start the webinar.
So, welcome, folks. Welcome to our webinar. This webinar is on the topic of cloud access, basically through the IAM, that is your identity and access management. So, without further ado, let's dive into it. So, first, let's see what the cloud actually is. So cloud can be defined as compute resources which are running on service providers' data centers, and you have to pay them to get access to their services. One of the features of cloud is it is easy to access, and you have a lot of flexibility in terms of creating resources, creating different objects, and building infrastructure or software on top of it. These are some of the common cloud flavors, or you can call them as cloud cloud versions or something. So they usually come in three flavors. That is infrastructure as service, where you get the whole infrastructure. You have to provision different resources like your VMs and networking and IPs and everything, and group them together to form something out of it. Then comes the platform as a service, where cloud provider maintains some of the things for you. So, for example, if you talk about the service, AWS has one service that is Light Sail, which is fully managed, not fully managed, but managed VMs for your deployments, for your websites, or for research. So there you do not have to take care of the networking and stuff. It is provisioned, and you just use it as a platform. On top of it, you can build. Then software as a service, where The provider maintains the infrastructure as well as the service, and you are just kind of the end user, where you are getting access to some services. For example, if you talk about Google Workspace, where you have access to the Google Drive, Google Docs, Gmail, and whatnot. So it is part of your software as a service. Now, let's talk about cloud access. Now we know what is cloud. We have to figure out how we can access it. I mean, it's not a kind of a Merlin's wand. You just wave it, or kind of the Harry Potter's wand where you wave it and say "Alhomo" and it opens. So there are some things which we have to do in order to get access to these cloud services and the underlying resources. So first is the console-based access, where we log into their website or we log into their web app with this some credentials. So, for example, they could be your emails and passwords which you use to create these accounts. For example, in case of AWS, you have two options. You can log in either via the root email account or you can provision the IAM users. And we'll talk about IAM users in a bit and login. Then comes the CLI based system. So here, what the thing is like we simply create some credentials for existing users, and most of the cloud providers they give us official CLI tools, so we can use those tools to log into these providers, and it happens in the backend through the API calls, access tokens, refresh tokens, and similar access credentials. And through these credentials, we can access the cloud services. We can provision, manage, delete, even move different resources with the help of the CLI. So it saves the effort of browsing through the um, web browser and clicking on things. And also one of the thing is it gives flexibility, because there are some things we actually cannot do with the web console. So some things are restricted. So for those things, CLI is the best option. And with these two options, there is one another option which is actually very widely used, and that is the programmatically access with the SDKs. So these SDKs are software libraries which are mostly created and maintained by the official cloud providers, and they are available in multiple languages. So let's say if you are a Python enthusiast, let's say another is a code, another want to do it in C. So whatever, they have the libraries for multiple languages, and with these libraries, we can access the cloud services. We can even write scripts to automate some of the things. We can write tools. So if any of you is in security, you might have heard about some tools like Paku, and these tools also use the SDKs to kind of provision, not provision, but kind of manage your interactions, whatever commands you're giving. Let's say you're enumerating something, let's say you're enumerating the IAM user. So they use it, the libraries. For example, in case of AWS, they use the Boto3. In case of Azure, there's Azure SDK. Again, in Google Cloud, they have the Google Cloud SDK. So these things we use to access the cloud services programmatically. We can script it, automate it, and whatnot. Now that we have talked about the how we can access it, let's see how or which type of credentials we can use. So first credential is the one that is being used for ages. That is the typical username plus password combination. Now this username could be your email address. It could be your IM username and whatnot. So these are used mainly in the terms of web-based access. So when we want to get access to a resource via the web-based GUI, we use these credentials to access it. Then comes the another topic, that is the access credentials. These credentials are mostly used in programmatic access, either via the CLI or via the SDK. So we use these, and they also have similar like some flavors like access keys. In AWS, we have the concept of access keys with the secret tokens, and we use it to authenticate to the AWS CLI and do it. In Azure, we have the concept of the device code or even logging through the credentials. So multiple providers have multiple ways to do it, and these are some of the common ways. Again, next comes the tokens. So these tokens also come in multiple flavors. You can have the long-term tokens, we can have refresh tokens, we can have access tokens, short-term tokens, and they are mainly used to get access for a short period or to certain resources. So What happens behind the scene is we have generated a credential logged in through the CLI, and we are using CLI to generate a resource or interact with the existing resource. So these CLI interact with the APIs of the cloud providers, and they generate refresh tokens, which are short-lived tokens, and through these tokens we are given access. Another is the concept of the service accounts, which is more popular in the case of GCP. So there we have the service accounts. We use the service accounts to provision or assign permissions to different resources which we provision. And after this, there comes the thing of single sign-on or federated identities. So now we talked about the username, password, credentials, but think about these things at scale. So let's say we have an enterprise. Let's say we have 100 users, and let's say each of the 100 users has to access, say, five services, five cloud providers. Now, for five cloud providers, they have to manage five different passwords, and it gets hectic when we think about it at a more larger level. So now we are talking about the 100 users. What if there are thousands of users? What if there is lakhs of users? Now, the complexity grows because it's very unrealistic to manage these much credentials, and that too securely. Like most often there is when we force users to change passwords or use password for multiple accounts, what they do is they just append some bits to last of the password or beginning of the password, and they use it. So for this we have a concept of federated identities or single sign-on, and these are the external identity providers, IDPs, which give you access to services with a single credential. So I can generate a credential, let's say for a user, I can give that user access to, let's say, three of the clouds, let's say Azure, AWS, GCP, and I can map it to a single identity provider. And from there, he can access all of these without managing three different sets of credentials. So that is the benefit of this, and this is also most widely used in enterprises. Now, let's talk about how IAM, what IAM is and how it works. So IAM is your identity and access management, and it is a tool or it is a process. You can call it a process to streamline control of the permissions policies or what resources the user is allowed to access. And how IAM works is, if you see the diagram, so in first part of it, the user is requesting access to a resource. Now, in typical scenarios when there is no IAM, so the user will be allowed to gain access to every resource because there is no way to check what access he has, like or what resources he can access. And to solve this, we have the concept of IAM where we have two portions. So first, the user is authenticated, and then the user is checked for the authorizations, which we will look into next, which we will look into the next couple slides. So let's talk about authentication first. So authentication is part of the identity service, and the authorization is part of the access management service. So these two are different terms, and if we talk about the authentication, so it is a process where we verify whether the user is who he is claiming to be. So understand this very clearly. It is a process to verify if you are who you are. So let's say someone calls me and say, "Ki, okay, I am your CEO, and give me, let's say, your credentials for one of the accounts." Now, here comes the part of authentication because I need to verify whether the person calling me is the CEO or not. Right. Now, if I have authenticated that this is the CEO, now I have to check whether I'm allowed to give him access. Right. So there comes the part of authorization. So it is used to verify whether the authenticated user has access to the resources which he is requesting. So again, understand this clearly. Authentication is for verifying the user, whereas authorization is for verifying the authenticated user's access to certain resource. I hope this is clear because this is actually something uh, confusing when you look at it anyways. So let's talk about some of the IAM components. So previously in the back slide, we if you look at the first pointers of both of these, so there is mention that IAM like authentication is part of identity, whereas authorization is part of access management. So let's first look into the identity. Identity is the process of provisioning credentials or user accounts to a particular user or a particular service. I'm iterating again. So, with the help of identity, we establish authentication, and with the help of access management, we specify authorization. So, with the authorization, we manage the resource access, and it is only applied when an user is authenticated. So, once we verify that a user is who he is claiming to be, we can then determine whether we want to give him access or not, or whether he is allowed to get access to this thing or not. Let's look into some of the objects. Right now, we have talked about the different credentials, how we can access it, what is IAM and whatnot. But let's talk about some of the IAM objects because these are what are used to make IAM work. So first and foremost, we have the policies. So policies are entities or objects which can be assigned to different other objects. These other objects can be your users, they can be your groups, they can be roles. And these policies are just a set of permissions, different permissions, which we define. And these permissions are then assigned to other objects. And then comes the concept of roles. So roles are objects which have permission to access the specified resource. So we create roles so that we can manage access at a very good level, at a very fine-tuned manner. So we can assign policies to these roles. We can assign policies to a lot of other objects which we will be seeing. So again, um, policies are the way to manage permissions. Policies can be assigned to other objects. These objects can be roles, groups, and users. And roles are objects which have permission to access certain other resources. And these roles comes into two flavors. First is either your cloud provider will be provisioning you some of the default roles, pre-configured roles, and then comes the concept of custom roles, where we define our own roles. And in these roles, we can further fine-tune the policies. Further, we can add or remove permissions depending upon the scenarios or depending upon the use cases which we are targeting. Now we have seen IAM objects, which is policies and roles. Let's look into the third object, which is the users. So users are the IAM object which have credentials or which can authenticate with the credentials. Now, we talked about these credentials before, like there is username, password, there is access keys, there is tokens, there is service account, and whatnot. So these can be termed as the users, and the credentials are the service account or the access key IDs or tokens or username passwords. So these are the credentials that can be assigned to a particular user. Then uses those credentials to access certain resources. Again, I'm iterating. Users are objects with the credentials, and user accesses resources with the help of those credentials. Now, the fourth component or fourth object of this IAM is groups. Now, we have defined users, but let's say we have a department, let's say we have a marketing department, let's say all of the marketing users need to get access to a certain resource. Let's say they want to access to a CRM that is hosted on cloud. Now, it is difficult to map access to every single user individually. So we can group them, and we can group them based on different attributes. Attributes could be their tasks or their role or what they're allowed to do or what they're not allowed to do. So again, take let's take another example. So let's say we have an organization and there's a help desk group. Now, in the help desk group, they need to be able to reset the password of the other users, and they can, let's say, create another user accounts and manage them and define policies, etc. So if, let's say, we have 100 employees working in that particular help desk group, so it is not feasible to assign the access to each employee individually. So we group them together and we assign these permissions or policies to the group, and through the group they can access it. And it is also very helpful when, let's say, key one employee left. We can simply remove them from the group and their access will be revoked. Instead of going individually, removing the policies, then deleting the account, it is much better and much easier this way. And it is used to streamline permissions in a single place. So we can define them in one place, we can add them, and we can have different groups. So let's say we have developers, let's say we have 10 developers and they want access to some resources. Let's say they want access to the compute resources or the databases. We can define the policies that, okay, they're allowed to access this group is allowed to access these resources. And from there, we can add the users, add the developers to it, and only they will have access to those particular resources and no one else in the organization. Now, we have talked about this. Just give me 1 minute. Let me have some water, and we'll continue in a minute. Now, let's talk about how this IAM actually works in the cloud. So first, let's see in the AWS. So when we are creating an AWS account, resources are provisioned inside that account itself. And account is a sort of a container through which different resources are being provisioned. And the account owner is the owner of these resources unless or until we specify another users and IAM things, which we will be seeing a bit in a bit time. So in AWS, we can also have we can also group together different accounts in organization. And through this organization, we can manage different accounts. So let's say we have two AWS account. One is for, let's say, developers. One is for, let's say, IT operations. So we separate them both in their own AWS accounts and we map them through the organization. So they will be inside a hierarchy where the organization will be on top and it will have two children. One is the developer's AWS account and another is the IT's AWS account. Now, there is another cloud provider that is Azure, and Azure manages these resources through an entity or container called subscription. So in Azure, we create subscriptions, and inside these subscription, we create and provision different resources. And these resources can be anything. Like when we are talking about cloud, it is a lot of things. Like there is serverless, there is compute, there is AIML, there is security, there is log analysis, there is analytics, there is ML, a lot of things. So everything can be provisioned. In AWS, it is provisioned through the account, and in Azure, it is provisioned through subscription. And in GCP, the same container is known as projects. So in GCP, we provision project, and inside the project, the resources are being spun up and managed in our gateway. So AWS manages the resources through the accounts, Azure manages the resources through subscription, and GCP manages the resources through projects. Also, there is one thing. So in case of Azure and GCP, they manage kind of a role-based access control, whereas AWS is kind of odd one out, where role-based access control has to be defined by the account owner. And in Azure and GCP, it's already built in terms of the subscription and product. Now, let's see some of the most common access misconfigurations that happen. And first of the thing is using the administrative account for day-to-day tasks. And it is true for all three of these pretty much. So in AWS, if you are provisioning an account, you create a root account, and you can pretty much do anything with the account. Although not pretty much, there are still some restrictions. So last month I was doing some research on AWS, and there was a certain IAM thing which kept tripping me for a long time. I even tried the root account. that. So I had to define policy and then map it, and then I was able to get access. So first is using the administrative account for everyone. And this is a pretty much bad practice because if anyone is able to compromise the resource, so let's again take an example. Let's say we have a VM running and which is publicly facing, and let's say there is a vulnerability. Let's say there is SRF, so our RC in the application. So anyone can exploit this, extract credentials for the root user, and then once you get the root credentials, it is pretty much game over because unless you rotated, the attacker is able to do anything. I mean, he can turn your bill to like thousands or even lakhs. I mean, he can spin up large VMs to crypto mining and whatnot, and you will just be getting very huge bills. Also, it is bad for high security hygiene because once you get accustomed to using the root account, it is a pretty bad practice. And like when I first started with the cloud, it was very challenging for me, and I used to do root account all the time. Then I made a mistake one day, learned hard way, and these days I'm just using IAM to configure and distribute the access to the resources. And this is the first of the common access configurations. Another is overly permissive policies. So it actually happens when you are using the policies that are provided by the cloud provider. So by default, they are overly permissive. And if you're using some of these policies or these rules, so you will get access to a lot more thing than is required by your use case. So let's take another example. So let's say you are simply trying to create a EC2 VM. Now, to create EC2 VM and like stop it, you need five or six policies. But if you are using the default roles or attaching the default policy, so they come with a lot of things like load balancing, allowing you to use elastic IPs and whatnot. So I mean, these should be defined when required, and by using the principle of least privilege, we can achieve that. And third thing is wildcard access to resource. So by default, when you are creating a policy, you are getting access to pretty much anything that is running with those policies or that can be managed with those policies. And this is wildcard. I mean, let's say I have a VM called EBC VM. Let's say I have another VM called XY. So if I want to get access to both of the VMs, I can simply assign them in my IAM policies or IAM permissions, and I can map it. But if I'm using the default credentials or default roles, I'm getting access to both of these, which might not be required for my day-to-day job. Right? Now let's see some of IAM's best practices. So first practice is define the policies very clearly and according to the use cases. So again, if I do not need to access something, or if I do not have the requirement to access some of the resources, I should not be able to. Why should I? So this is why we should define IAM policies very clearly, and it should be mapped to the use case. So again, let's say there is one developer, and that developer is let's say working on the backend projects, and he needs access to a certain database and a certain VM. So he should be only able to access those resources, the database that is required and the VM that is required. Unless he needs some access to other resources, it should be blocked out. Then again comes the topic of the role-based access controls, which is again the same thing. So access should be given to the users based on their roles. If they do not need to access anything, they should not be given access to those. And comes the third point, which is enforcing transparency and strong password policies. Because even if we are having credentials, even if we are having the least privileged credentials, if they are issued and there is no ambiguity in place, or if there is not there is a weak password in place, so it can be easily brute force. And if I mean it happens almost every day to most of the organizations, like someone brute forced a way out of it. They got access to the resources they should not have. They abused it. And it is pretty much threat actors actually look out for. So if they get, let's say, an email address of an employee and they start running it across different services, they identified, okay, so this account is registered in, let's say, AWS or let's say Azure or GCP. So they can try to brute force. And I mean, I keep seeing, here's a funny thing, I keep seeing those maps which shows you have to wait millions of years to brute force this digit of passwords. It was actually true when less powerful GPUs and stuff, but these days it's, I mean, I have seen people running 20, 30 GPUs and they're cracking passwords just like this. I mean, playing, they're cracking passwords, and it, I mean, it was pretty scary when I first came across it. And there was one guy I was talking to, and he told me about his writing assessments, and he was like, "It's not secure, or it is kind of a myth that passwords take too long to crack. They can be cracked given enough money and enough time and enough resources. So enforcing of MFA is a must. And even if you have a strong password, combine it with MFA, use it on your personal account, and this is kind of a plea from me to you. If you are using something online, whether it is your account, whether it is your social media account on Facebook, Instagram, or if you're using Gmail or Outlook or whatever, if it has the option to enable MFA, please do. And another thing, like people keep MFAs, like text-based MFAs, they are not secure, not secure. Okay, but still, something is better than nothing. So, folks, please do it. It is a best practice, and it is a really good thing to have MFAs, because if someone guesses your password, or if even if they are able to brute force your password, you need to bypass another barrier, which is MFA, and it is something that will uh, cause most attackers, because most of the attackers, they try to go for the low hanging fruits. They do not want to do this. I mean, alpha bypass is possible, it's doable, it has been done, but again, it is a very strong thing if you have it with your passwords. And last but not the least, if you have set up IAM, if you have configured the policies, if you have given access, if you have given fine-tuned access to the users, groups, or whatever objects, audit the logs. Check whether it is working, whether it is configured. Other situation, so in case of AWS, there are different things. So in AWS, you have different policy versions. And let's say someone is malicious, they map the policies. So what they can do is they can create a policy, first policy version, which is, let's say, giving them access to everything. Then they can change the policy versions. And then let's say they have a second version which is least permissive. So if someone checks, they will see, okay, this is this, and for from the like just a surface look, it will look like, okay, they have the least permission. But again, they can switch back to the old policy, which is overly permissive, and they can do malicious stuff. So with this, it's demo time. So guys, let's do a demo. And before this, can someone wait, I think this screen is sharing, right? Let me just ask again. Anyone can give me thumbs up if you can see the screen. Voice is not clear. Guys, folks, my voice is not clear. Can someone let me know if my voice is clear or not?
No,
Okay, thank you. Okay, now let's look into the IAMs. So first we will look through the AWS, then we will look through the Azure, and then we will look through the GCP. So this is the AWS. We'll first start looking from the policies. If you check here, the policy type is showing this is AWS managed, and we can also see AWS managed job function. And if we see, there are different types of policies here: AWS managed and AWS job function, which is kind of a role based. So you can see like administrator access, billing database. So these are pre-configured policies. Now let's check one of the policies, which is system administrator. Now, if we are seeing this policy, we can see we have different access, easy to this, easy to that, and whatnot. And if we check this effect line, we can see in the resource section, it is marked as star. This star means wildcard access is given to whoever this policy is attached to, and he can access or they can access whatever resource is running, whatever resource they want to create, which is falling under these things. So this is the default policy for the job function. If we check these policies, these are for AWS managed policy for different resources. Let's open any of these. Let's open EC2. So in EC2, we can see container full access, EC2 full access, read only access deploy. Let's open any of these policies. Let's open this one, container service role. Now, different policies, different permissions we have allow this, right this, and again elastic load balancing this, and again the resource is given wildcard access. That means they can pretty much do anything that is falling into these conditions. And this one is actually this particular policy is actually attached to instance which is running the EC2, and mostly this is used for the ECS, which is Elastic Container Service. Let's open any of the user policies. So let's open administrator access. This one. Here we can see action is star, resource is star. This means this policy can access anything on any resource in this particular account. So these are kind of pretty bad things. So we have the option of consumer managed policies where we can define our own policies, and we can um, have different resources. We can provision it like this. So this is one of the policies. So here you can see like we have this one. This one is for getting the ECR tokens, and it is fine. So if you can see like there is like um, I do not want to show you the exact things, but if you see the very last, like you can see, okay, this is giving access to this particular resource only. And these kind of things are something that are considered as best practice when we are talking about the access at scale, or when we are talking about the access in enterprise. So just give access to a particular group of resources and that's it. Give the permission that is required and that is. So this is policy. Let's see. Since we were talking about the policies, so let's see how we can create the policy. In AWS, we have options. We can either use the GUI based, where we can select any of the resource and we can simply add here this, which is the start option. And then we have the different fine-tuned options. We can select, let's say, if you want someone to, let's say, get the log file, so we can use this one. Let's say if we want someone to, let's say, list the endpoints. So we can do this one, proxy endpoint. So something like this. So these are fine-tuned ways. And then we have other things. And also, I want to point out something. So in most of the cloud policies, you will see two things. And one is the get, other is list. So these two are easy to confuse with. So list is used for listing all the resources of that particular attribute, and get is for getting details about a particular object. So let's say if I'm using list EC2 instances, so I'll get all EC2 instances that are running and that are allowed to be accessed by the user. But if I'm using get, I can get details about a particular instance. So that is the difference between these two. And this is the policies. And another option is we can create these with the JSON. Then comes the rules. So we can define different rules. And these roles are for different types and different things like SAML. SAML is mostly used in the SSO and OAuth kind of things. And we can define these for different use cases, and we can say, okay, you business and what do you want to do? Just click this and just again, we have to either define this, use this policy, or we can create our own policy and it will be available here and we can map it. The time is running short, so I'll be moving through the things quickly. And then we have the users. Again, we have different users, different policies, different groups. We can define user. We create a user. And another option is this, if we use this, so we give them access to the EC2 console, through which I'm right now using it. Or if you do not want to give them access to that, we can again comes the thing. So we can see like we have different groups here. So we can either add the user to a particular group, we can copy permissions from other users, or we can attach policies directly. So we can create a simple policy and we can attach it to a particular user. Although it is better to use the concept of the groups, attach policies to the groups and add users to the group, but I think policies can be assigned to users individually as well. And then there is a concept of permission boundary in AWS, which is something very good because we can use it to define the maximum permission a user can have. So let's say if I select this, let's say um, I want user to have access to one Lambda only. I can select this. Let's say I want him to have access to Lambda here only. If I give this, if I set this permission boundary, so doesn't matter whatever permission the user have, the boundary will be this boundary. So the user will not be able to access other things apart from whatever is defined in the permission boundary. Then we have the concept of user groups where we can simply have different users for different groups. And we have different users right now. And again, in the groups as well, we have the option to attach policies. Either here, again, we have different options here like attach policies and create groups. And whatnot. So this is for the AWS. Let's look into the Azure. So in Azure, we have the concept of subscription. And if you see, there is one subscription here. So there is one subscription, there is another subscription here. And inside the subscription, we are provisioning resources. And the subscription is used to manage different other objects like resource group. Inside subscription, we can create resource group, and inside resource groups, we are creating different other objects or resources. And here is a tricky part. So actually, when you're using Azure, your permission is typically being managed by the Azure Active Directory, or as it is known as these days as Android. So just give me 1 minute. I'm just gonna stop screen sharing for one moment. I need to hide something, and then I'll just show you how this works. Okay, can anyone confirm if you can see the screen? Thank you. So let's first see about the users. So in Azure, we have the concept of different users. We have different users. These users have a username, they have the user type, they have the uh, different attributes, let's say identity or company or whether they are internal or external users. So if we create a user, we have two options. We can either create an internal user. We can also invite another user from outside environment, which is something when you, let's say, want to invite the consultants or if you want to invite someone to do some IR on yours. So you can simply either invite them or create another user account. Or anyways, that is the kind of mapping. Let's see about this particular user, which is logged in. So we can see this. Okay, so this is the user, this is the object IDs and group membership one. And if we see which groups this user is part of, so we can see okay, this is part of all users group. And we can see okay what roles are assigned to this user. So we can see like there are different roles assigned here, like the application admin, global admin, security admin. These roles kind of have different permissions that are assigned to them. And these roles, these groups, also they have the concept of administrative units, which are something where you define, let's say if you want to have a help desk and if you want to assign something to help desk, let's say if you want them to reset some passwords or if you want them to get access to something like let's say Office 365 or Teams or whatever or SharePoint. So you can assign these permissions there and it is a good way to do this. Now comes the concept of groups are again the entities where we map different, where we define some positions and we add different users to these groups. And I think this is all for the Azure because it actually gets complicated when you deal with the Entry ID because there are lots of moving parts. So for the beginner purpose, I think this should be fine. Since we have only 10 minutes, so I'll try to wrap it up really quickly. So let's move to the GCP. So in GCP comes the concept of the service accounts. In GCP, we have different, again, we have also the ability to kind of create groups. We can create policies, roles, and we can map it. And it also works the same way as it works in the others. Most likely, like, you can compare it to AWS, where that's kind of the same thing. So we have different groups and we have different roles. We have different policies or permissions that are assigned to these particular ones. So if you see here, you can see okay, access approval request dot get, request projects dot list. So these are the permissions that can be assigned. And if you talk about the default rules, so let's open any of the default rules. Let's actually search for it. So let's say I don't know, cloud. Now, if we talk about this, there are different rules available here. Let's say developer. If we open it, we'll see it has like 64 permissions that is attached. And most of it won't be required for the developer to do their day-to-day jobs. So for this purpose, we can create custom rules, and we have a custom rule here. And in this custom rule, we can define different permissions. And these permissions can be mapped according to the access they want to get. And it can be further fine-tuned with the access to certain different resources that they can access. So let's open any of these accounts. Let's open this account. If we added this particular account, we can see, okay, it has access to different roles, it has access to different permissions, and we can also add the other roles or we can add the conditions. So we can add, let's say, condition like this, and we can give it any title. We can define permission. Okay, so if let's say we want them to have access to a particular resource type, we can map it. Let's say we want to give them access to, let's say, in a particular time zone. Let's say someone is working in the Indian time zone, so they want to get access from, let's say, 10 a.m. IST to 6 p.m. IST. So we can define these things now. So with this, this marks the end of the webinar, the end of the term. And here, we have actually released a course that is the cybersecurity engineer, and we're giving 20% off. So if you want to get access, just copy this code CCC20 off, and just go to our website cyberwarfare.live, and if you go to the course, I'll just show you how we can do it. If you want to get access to this, there is also this code. You can simply copy this code, enroll now, view your cart, apply the coupon, and if you apply the coupon, you will get the 20% off, and you can purchase it at this price. So with this end of the webinar, if you have any questions, feel free to ask, and thank you again for attending. Yeah. Okay, so coupon code is this CCC20 off. And if you visit the website, so I'll just repeat it again, and I will remove this. You have to visit our website, cyberwarfare.live, certifications, ethical hacking, and this cybersecurity engineer. You will also see the same coupon code here. Just copy it, copy this code, click on enroll now, click on view card, apply the code here, and you will get the 20% off, and then you can proceed to check out and do the payment. And do we have any other questions? Yes, we do offer different certifications. You can check our website. I'll just paste the link in the chat so you can check it there. I have just pasted the link in the chat and I'll just pin it. So you can visit our website. You will see different. Can you send me guidelines for those certifications? Send the link. I'll also send the link to you personally. So you can visit the website and you can see different certifications we have, and then you can browse to see what interests you. Do we have any other questions, or shall we end the webinar? If we do not have any other questions, we will be ending the webinar in 2 3 minutes. Since we do not have any questions, we will be ending the webinar. Thank you, folks. Thanks for attending and enjoy your weekend.